So today we'll be looking at cones, which are circle versions of pyramids. So we'll see all of the formulas that we're looking at here in this section, lateral area and volume, are very similar to the ones that we studied in pyramids, except for we replace everything before that had references to a base that wasn't a circle with a base that is a circle. So the one in particular that we're going to focus on in this class is that of a cone, a right cone. And a right cone simply just means that the vertex of that cone is directly above the center of the circular base. And so if we finish that sketch right below that, we can go ahead and label some of the features of this cone, with the top being the same as the top of a pyramid. It's called the vertex. You guys have that the altitude is the line that you would drop to form a right angle, so that it is called a right cone, because you form that right angle with the radius. When we measure the altitude, it gives us a unit of measure that measures the height of the cone. Okay, and that height is what you would envision if you were standing at the top of that cone and you were to drop, and there was a hole. Let's say we're referring to this as a birthday hat, and if we were to drop let's say there was a hole there, and you were to drop a line down, that would measure the height of the cone, and as opposed to throwing the rope over the side of the birthday hat right here, we see that this measurement of the height is at a slant, so this is called the slant height. Okay, so if we think about the lateral area formula that we learned before for pyramids, we knew that it was a half P times L, where P stood for perimeter. Now, if we think of the lateral pyramids as the circle versions of pyramids, and this is the equation for a pyramid lateral area, well, what we would then want to replace is, perimeter of the base. Well, what's the perimeter of the base of a right cone? Well, the base of a right cone is a circle. The perimeter of a circle is the circumference. So we're going to go ahead and substitute that out and get 1/2 2 pi r times the slant height, L. Now, if we reduce things out, the 1/2 and the 2 reduces to 1. So we get that our lateral area formula is equal to pi RL. Okay, so let's go ahead and highlight that as an important formula for this section. Okay, and the other formula that we'll look at for cone will be that of volume. And the volume of a pyramid, we saw that it held a third of that of a prism. So a third times capital B for the base of the area, and then H for the height of that prism. Okay, so if we take a look at this formula, we're going to think of this as the circle versions of pyramids. And if this is the formula for a pyramid, the base of the pyramid happen to be squares or a regular polygon. For this one, it's a circle. So what is it that we're going to replace capital B with? The area of the base. We're going to replace it with the area of a circle, so pi r squared times h. And so this is the formula the other formula for cones that we would have to know. Okay, so let's go ahead and scroll down and do one quick problem here. Okay, so let's say there's a box to the right, and these are the given information that you have. Okay, and I'm gonna go ahead and pick something that is not as direct, that the information isn't all there for you. So let's go ahead and take a look at C. On C, we're given that the radius is radical 2, and I'm gonna go ahead and fix the volume. The volume is supposed to be 2 pi, so let's go ahead and stick a pi there. Okay, and I'm now going to do that problem where they're giving us the radius, and then they give us the volume. So if I write down the formula from the previous page on volume, I have volume is a third pi r squared times h. Okay, so in this case, we know our given is that the volume is 2 pi. we're given that the radius is radical 2. And so we have enough information. It looks like the only unknown we have is h. Pi is a constant. Remember, it's an irrational number. So when we see a symbol like that, we just think of it as a factor of the right-hand side. So if I'm trying to isolate h and all of these values are factors, we can divide the whole thing over. If I want to treat the fraction 1/3 separately and do it in multiple steps, I can. So for example, some students might feel more comfortable if they multiplied both sides by 3 first. In doing so, you guys get 6 pi equals pi rad 2 squared is just 2, and then h. And then now we're left with just to solve for h, we divide both sides by 2 pi. The question is, what happens when you divide 6 pi by 2 pi? Okay, we see that 6 and 2 reduces to 3, and the pi's are constant, so they'll cancel out. We get a value of h. Okay, I'm going to go back to my figure now. So I know h is 3. I know that the radius is radical 2. How do you guys think we were going to solve for L? Okay, so L forms a right triangle, and L happens to be what of the right triangle? It happens to be the hypotenuse. So we have enough information to use Pythagorean theorem. So in my Pythagorean theorem, I'm going to go ahead and erase this here. Pythagorean theorem to solve for the missing side length of that triangle, which is the slant height, and we need that information for the lateral area. So L squared is equal to 3 squared plus radical 2 squared. So the hypotenuse squared is equal to the 2 legs squared. So when I go ahead and solve for that, I get L equals 9 plus 2, 11. So if I take the square root of both sides, L is equal to the square root of 11. In most cases, you guys want to leave the values with radicals in it because that's an accurate answer as opposed to punching it into the calculator and giving a decimal approximation. Okay, so now to finish off the information here, we have lateral area is equal to 1/2 times pi RL, or in which case when we were simplifying, we got 1/2 2 pi r times L. We simplified that to be just pi RL. So this is the formula that I'm going to start with. And if you forget, you guys think of it as the half the perimeter times the arc length, which simplifies down to pi RL. So now if I substitute R in and L in, I will get R is radical 2, L is radical 11. So radical 2 times radical 11. So if you remember the rules of multiplying radicals, rad 2 times rad 11 is the same thing as putting both 2 and 11 inside the same radical. And so we get 2 times 11, which is pi radical 22. Okay, let's think about what total area is. I didn't give you guys a formula for total area, but you should be able to figure it out. If the lateral area is just the sides of the cone, you have that the total area would include the base. And well, what is the base? The base is the area of the circle. So if I take pi radical 22, which is the lateral area, and add the area of one base, I would get that the area of one base is 2 pi. So hopefully this is enough for you guys to go ahead and finish off A and B. And we will meet up soon to discuss any problems that you might have. Please try the problems that you see online.